Today we're going to learn how to factor quadratics with a lead coefficient of 1. All right, to get started, we want to look at the word factor. That's what we're doing today. And when we factor, what we're doing is making things more complicated. So instead of having this polynomial right here all written out all nice, what we're going to do is essentially pull it apart into its two factors. Now, that means we're going to have stuff in parentheses. We're actually going to end up with, in this case, two binomials in those parentheses. But just a quick refresher, if we had a number like 2 and we wanted to factor it, we could say, what multiplies to give us 2? Well, 2 is a rather simple one because it's prime. The only thing that multiplies to give me 2 is 1 and 2. 1 times 2 is 2. The other thing you might notice is that I chose 2 because it's right there. And so what we're going to do is we're actually going to be able to pull this apart and do x plus 1 and x plus 2. Okay, a little bit of magic here, but let me explain. In order to factor a trinomial or a quadratic with 3 terms, what we do is we list factor pairs of the constant. And so the constant's the number all the way at the end, that one right there. And then the second thing we do is we find 2 factors that actually add up to the middle coefficient. In this case, they got to add up to 3. So what we say is we have 2 numbers, 1 times 2, and that equals 2. But 1 plus 2 equals 3. All right, that's going to feel really weird. But let's take a look at another example. I picked this one to begin with because just 1 times 2 and 1 plus 2. When we look at the second example, we have one that's a little bit different. The first thing we're going to do is we're going to list factor pairs. And so when we list the factor pairs, we have, well, 11 again is prime. So 1 times 11 equals 11. 1 plus 11 equals 12. So it works out that we get our number there and our number there happen to be the same as our 2 numbers in our trinomial. So we can go ahead and write in parentheses u plus 1 and u plus 11, because we have those 2 factors. All right. Let's do one where it just doesn't happen to be prime. This one, for example, if we did 1 times 10, we would get 10, but 1 plus 10 equals 11. But we wanted it to equal 7 because we're looking for it to equal the middle number. So that's a problem. So 1 times 10 didn't work when we tried to add those up. So let's try 2 times 5 equals 10. Well, 2 plus 5 equals 7. And guess what? That's exactly what we want. So what 2 numbers did we have that multiplied to give us 10 and added to give us 7? And in this case, those 2 numbers are 2 and 5. Y plus 2 and y plus 5. Okay? So when we're factoring, we're actually pulling apart into 2 things that if we were to distribute them again, we would end up back to the polynomial we started with. In these next couple examples, when we look at examples 4 and 5, it gets a little bit more complicated. This one, you're going to notice we actually have a negative 18. Negative 18. So the negative is going to stick with that number, and then we have a positive 17. So we're looking for 2 numbers that multiply to give us positive 17 and add to give us negative 18. So if we go ahead and try to find the factor pairs, we might notice that what multiplies to 17? Well, actually, the only one that we can really think of is 1 times 17. The catch is that 1 plus 17 is 18, and it's supposed to be negative 18. which means that that's not going to work. So can we come up with any way we can end up with a negative 18? Well, if we do negative 1 times negative 17, we still get positive 17. So that still works for our constant. But when we do negative 1 plus negative 17, we end up with negative 18. So all we're doing is really listing the factors that work. Now this one, just because we had a negative in there, we had to adjust and do something a little bit more sneaky. And so what we'd end up with is x plus negative 1, or I could just write x minus 1 and x minus 17. Number 5, what you can see is 20 is a little bit more complicated. I can think of a lot of numbers that multiply to 20. 1 times 20, for example. But 1 plus 20 equals 21. And remember, what we want is a positive 12. So I could do 2 times 10, but 2 plus 10, well, there we go. That's it. So I didn't have to do a lot of thinking. The hardest math I was doing was just multiplication and addition. But I got my two numbers. It's 2 and 10. So I'm going to go ahead and rewrite this as j plus 2 and j plus 10. And I just realized I used x's over here in this one. So if we want to do that correctly, we should probably pay attention to the fact that they're both p's. So we can see that each of these, we're listing out the factors of the last number in the list, and we're trying to figure out the two numbers that would multiply to give us that number, while adding to give us this one in the middle. Two more examples here. Again, we have 20. And this time, the 20 is with a g. So it's really going to end up being the same thing. We actually don't need to do the math again. So I'm going to try to make it a little bit more complicated by tossing in, see what happens if I switch this out. I'm going to switch this out just to give us some variety. What if this was a minus 13? Because I think you guys are really on it. So when we do the minus 13, we notice that we need two numbers that multiply to give us negative 13. Well, I can think of 1 times 13, but that would give me positive 13. So what about 1 times negative 13? That's negative 13. But what about 1 plus negative 13? That's negative 12. And what I'm looking for is a positive 12. So if I just switch it around to make it negative 1 times 13, now I end up with positive 12 when I add that together. So that's going to work out perfectly for me. So I'm going to use the g minus 1 and g plus 13. So we have to be careful. The number one mistake I see people do is they aren't paying too much attention to their negatives. So this one, on our final example here, example 7, we have a minus 6x and a minus 16. So I want to remember to multiply two numbers to get negative 16. Obviously, the first one that comes to mind is negative 1 and negative 16. But if I did that, that'd be two negatives make a positive. So I just need one of them to be negative. And when I do that and I multiply those together, that works. But when I add them together, negative 1 plus 16, I get positive 15. And that's no good. I'm looking for numbers that add to negative 6. So if I do negative 2 times 8, I think that might work because negative 2 times 8, that checks out. But what about negative 2 plus 8? Oh, I got my 6. Now 6 is close, but remember, I want a negative 6. So 6 is still wrong. So there's one little change I can make that'll make that positive 6 into a negative 6. And that's if I do negative 8 and positive 2. It's still going to give me a negative 16 if I multiply, but if I add them, I get the negative 6. So I finish it out by writing my two parentheses. My variables this time are x's, and I have a -8, and a +2. It doesn't matter which order we go into because multiplication is commutative. Today we have learned how to factor quadratics with a lead coefficient of 1. So subscribe, like, and keep learning abundantly.